Kia ora team, my name is Mr. Dana and today I'm going to talk to you about rates of change. Rates of change are simply gradients, or the gradient function of something. So you might be given a question where they tell you a volume of a cube is v equals x cubed. So you might be asked, find the rate of change of the volume with respect to the side when x equals 4. So what that means is, what is the volume changing with respect to the side? Or the derivative. So can we differentiate that? Yes. Multiply by the power, take 1 off the power. And now we want to see what happens when x equals 4. And so if we plug in, we get 4 times 4 is 16 times 3, 48. Now, let's have a think about this in units. If I gave you the volume of a cube with x in centimetres, then the volume is in centimetres cubed. And so the rate of change is centimetres cubed per centimetre, because it's a rate. So as the side increases by 1 centimetre, the volume will increase by 48 centimetres when x equals 4. Does that kind of make sense? So you don't need to worry about the units so much, but all you need to do is differentiate and substitute the value, which is exactly what we've been doing thus far. You might be asked for a similar question where find the volume, find the rate of change if a circle has an area pi r squared. Find the rate of change of the area when r equals 3 centimetres. Well, what you need to do is you need to once again differentiate, because you're looking for the change of area with respect to radius, multiply by the power, take 1 off the power, and then you just plug in when r is equal to 3. And so what we're saying is 6 pi centimetres squared per centimetre. What that means is, as the radius increases by each centimetre, the area increases by 6 pi centimetres squared, right? But that's only happening when r is equal to 3. Don't worry about the units, but all you need to look at is differentiate and substitute these values in for r. Okay? Sometimes it might be harder to figure out what these r values are because they might ask you it in a different way. So the same question up here, I could be told volume of a cube is v equals x cubed. We could be asked to find the rate of change of the volume with respect to x when the volume is 27 centimeters cubed. Okay, this question might look a little scary, but the thing is, we're still finding the same thing. We need to differentiate, multiply the power, take 1 off the power, but now we don't know what x value we need to plug in, but we know that v is equal to 27. So v equals 27, what's x equal? Well, we know that v equals x cubed, so x must be 3, so we can substitute 3 into here, and we will find, coincidentally, that the rate of change is also 27 centimeters cubed per centimeter. And that's kind of really nice. And so sometimes you'll need to work out what the x value is based on the volume that's given. I hope that helped. All you need to do is, this is exactly like finding a gradient. You're differentiating and you're substituting. Rates of change don't get that much harder, so just keep on keeping on. Thanks guys, I'll catch you later.